Hello, and welcome to the Badger Talks podcast, the podcast that shares interviews with experts from the University of Wisconsin-Madison community about their work, research, and a little bit about what they're like as people. I'm your host, Buzz Kemper. Today, we're focusing on astronomy, and I'm happy to have as my guest UW-Madison graduate student and very soon-to-be PhD recipient, Melissa Morris, who in just a few days will be known as Dr. Morris. Melissa, thank you so much for doing this. I really, really love astronomy. This, to me, it's like where we came from, how all this began. There's so much. It's so big in every sense of the word, and here you are studying it. So I assume you have a very big brain, and you're doing it.
I hope so.
You are also about to become Dr. Morris. Is that correct?
So close, very close. Yep, about a week away.
Okay.
Less than. Oh no.
Yeah.
That's a good thing.
on Friday. So how does that work? You defend your thesis,
Correct.
And then what happens?
So the way it works is you have this committee of 5 people that you get to choose, which is pretty nice. So I have a lot of people that I know and trust on there. And I wrote this really long document, really long, that I sent off to them for comments. And then once I defend, it's basically this big event where I get to invite a bunch of people within the department. And then I also have like my mom, my brother, my partner coming out. It's going to be fun. And so I give this talk. Afterwards, I sit down and chat with my committee in kind of like a one-on-one session. And then they come out and they're like, congratulations, you're a doctor. We pop some champagne, have a nice time. Yeah.
Excellent. Cool. Well, and that's interesting because that's what I want to do here is talk about what's in your thesis, what you've been studying, and what you've found out. So from what little I know, it is the environments in which galaxies exist, correct?
Correct.
Okay. So what is it that you are looking at, and what is it that you've found?
Ooh, this is a great question. So what I'm looking at is I do look at galaxies, but I don't look directly at them. You see, when you think of a galaxy, maybe you think of just this big collection of stars and gas that are swirling around each other. Maybe you think of our own Milky Way. And usually when people think about space, they think it's kind of empty. Mm-hmm. But in reality, there's actually a lot of stuff in that emptiness. There's a lot of gas, a lot of hydrogen and helium gas that's left over from the Big Bang. But it's really hard for us to observe a lot of that. It's hard for us to observe it in the same way that it's hard for you and I to look at the air around us. It's just really diffuse for the most part. However, when you get into regions of space where, say, you have a ton of galaxies that are all right next to each other, like in a galaxy cluster where you have thousands of galaxies that are all swirling around each other. Maybe you might think of some of the early James Webb photos that came out of galaxy clusters all right next to each other. And these are some of the most dramatic regions of space where you have a ton of gas, and that gas can actually affect how those galaxies interact with each other. But that's not the only region where you can see that happening. You also have these things called galaxy groups, which are not quite as large as clusters are. They tend to host like tens of galaxies, but they're way more common. Our own Milky Way, for example, is in a galaxy group with like the Andromeda galaxy. And between us, there is a lot of this gas that's really hard for us to see. So the point of my thesis is trying to understand how much gas there is between us without directly looking at it.
So I'm familiar a little bit with dark matter. Is that a gas, or what is that? Is that a different thing?
That is something different entirely, but okay. I'm really glad you brought that up. You think about maybe you've seen this pie chart or you've heard of this before where like 95% of our universe is stuff that we can't see. And when we say that, we mean like 75% is made up of this thing called dark energy, which I couldn't tell you too much about. If I could, maybe I'd have a Nobel Prize. But then there's also this stuff called dark matter, which I also can't tell you too much about, but essentially this stuff that we can't see, but we can observe the way that it affects galaxies and stars and how they move based on its gravitational force that it exerts on everything. But that's not gas. What it is, I don't know. Great question for science. But what I'm talking about is that 5% of the universe that we technically should be able to see. It's matter, like you and I. We call them baryons, but we can just call it matter. And so this stuff that we technically should be able to see, but is just really hard for us to observe because of how diffuse it is. So that's what I'm referring to.
Okay. So are baryons part of the gases that you are studying, or that is?
Yeah, exactly. Okay. So the baryons are like, that's the gas that I'm studying. All of this gas, like you can just think of hydrogen and helium. That's the gas. Like that's what the gas is made of, and hydrogen and helium are baryons.
Okay. This is probably kind of an arcane question, but I'm used to gases having names that are singular: hydrogen, oxygen. Why baryons?
So baryons is like a catch-all term for matter, like visible matter. So we are all baryons, right? You're made up of baryons. I'm made up of baryons. It's not the name of like a specific gas as much as it is a name of an entire category of matter.
Okay, that is clarifying. Thank you.
Yeah.
Now, from studying these galaxies and the gases in which they swim, basically, what does that tell us, if anything, about the origins of the universe? Does it tell us anything more about the Big Bang or what happened before it or after it? How does that fit into the picture?
Yeah, that's a really good question. So I don't know that it can necessarily tell us about anything before, but what it can do is understanding how much gas is here can really help us understand how galaxies evolve and how that gas interacts with galaxies. Because for a long time, astronomers have really looked at galaxies as evolving as just kind of like this closed box, right? Like you put a galaxy in a box and the only thing it does is just interact with what's in the box. But you don't really think about a galaxy interacting with its surroundings and those surroundings interacting with it. So this is something that astronomers have, over the past few years have really started to begin studying and trying to learn about how does this really complex cosmic ecosystem, if you will, result in the galaxies that we see today. Yeah. Wow. And so that's one way that we can kind of think about it. The other way is kind of goes back to this matter of baryons that we were talking about. I said 5% of the universe is what we should be able to see. And this is all based on things from big, complex cosmological studies of things like the cosmic microwave background. It's a thing for Google later.
There you go.
And so based on these, we have these rough ideas of how much of what is in our universe. However, when we actually go out and look at our universe and try to count up all of the baryons that we see, because like I said earlier, we should see them. We don't see all of them. In fact, of the 5% of matter that we're supposed to be seeing, we only see a fraction of that. And so the idea here is that, well, perhaps a lot of these baryons that we're not seeing are all in this dense gas that is just really hard for us to look at.
And when you say seeing, are you talking about literally we are able to put our eye to a telescope and view that, or are you talking about we are able to detect it in other ways?
That's a really great question. So I generally mean detect.
Okay.
Because we use all different kinds of wavelengths of light to study space. And so not just at the visible, although the visible is really helpful, but all across the spectrum.
In studying this, what has surprised you the most, either in terms of where galaxies have come from or where we're going, or just the environments in general? Has there been, I'm assuming you've had a few I can't believe that moments. So tell me about one or two of those.
I have had a few. Unfortunately, some of them were just due to bugs in my code.
Oh, no. Well, that's okay. That happens. Yeah.
But a lot of it, I will say, like, fairly recently, whenever I first started actually making measurements of just how much gas there is, one thing that surprised me was that based on the measurements that I was doing, there wasn't as much as I had kind of expected. I was kind of thinking, oh yeah, it's probably all here. We're probably good. But it wasn't. And that's kind of one thing that's exciting about science is that, like, you think that you're about to solve a problem. And then when you get to the point where you're like, aha, problem solved, maybe, you realize, oh no, it's actually a lot more complicated than we thought it was. Mm-hmm. And frankly, that's one of my favorite parts about science is just getting to ask more questions. And because even though you didn't solve the problem, you still have a better understanding of what's going on ultimately. We can say, oh, well, we didn't find all of the baryons, so that must mean that something else is happening to them. What could that be? And there are already people that have ideas of what that could be. Coming up with ways that we can try to look for them, ways that we can try to go about answering these questions is something that is really fun and really exciting to me. It requires a lot of creativity, which is not really something that people typically associate with scientists. Yeah. But surprise, you need to be able to put these weird puzzle pieces together and just kind of see the big picture.
You have talked a little bit before when we were off the record. You were talking a little bit about these massive I think you called them supermassive black holes. Mm-hmm. OMG. Okay, yeah. Please, yeah, let's dive in, but right. Not literally because we'll never be heard from again.
That'll be very bad.
Please tell me about the supermassive black holes.
I would love to. So I've talked a little bit about, measuring this really hard to observe gas, but I never really said how we do that. And how I do it is, like you just said, using these supermassive black holes. So what a supermassive black hole is it's a okay, let me try that.
It's a really tiny blue square.
That's all. Yeah. Name's a little misleading. No.
Oh,
here.
My gosh. That would be the Monty Python explanation, right?
Let's try again. At the center of every galaxy exists a supermassive black hole. You might have seen some of the images from the Event Horizon telescope that came out a few years ago.
Yes.
I definitely was one of the nerds that was like, look at this fuzzy thing. It's a black hole. Yeah. And those were both supermassive black holes, by the way. And so when you think of a picture of a galaxy, maybe from JWST or Hubble, you might think of, you see these beautiful, maybe spirals that are coming off of it or something or other. But at the center, there's always this really bright region. And at the center of that really, really bright region is where the supermassive black hole is. And so sometimes these guys are just hanging out there slowly, consuming matter from the galaxy little by little. But sometimes something weird in the galaxy will happen that will send all sorts of matter straight towards the center. And this results in the black hole gobbling up a ton of stuff really quickly, essentially. And when that happens, you get all sorts of crazy effects. It's really... really kind of wild. It's a huge area of study. But one of my favorite effects that you get are these really high energy jets that shoot out of the black hole. And you can only see them for the most part at radio wavelengths. So this is using these really large radio arrays, maybe like you've seen in the movie Contact, instead of using a typical telescope that you might think about. And so usually when these black holes spit out these really high energy jets, they just kind of follow this really straight, thin line, and they look cool, right? But sometimes if you're in one of these denser regions of space, like a galaxy cluster or a galaxy group, that galaxy hosting that supermassive black hole, you know, is probably moving through the group or the cluster, orbiting around. And as it moves through, the dense gas that exists in that group or cluster starts to push back on those jets, and it actually bends them backwards. It's very similar to if you're riding a bike down, I don't know, on the nice lakeshore path, and you have the air flowing through your hair, kind of pushing it back. Really similar idea. And it turns out that by observing these jets, we can actually back out a measurement of how much gas is there to be responsible for pushing it back.
Okay.
Yeah.
Now, so if I think of these jets as like an exhaust, so it's pushing back. Does that mean it's propelling the black hole the other direction?
Not exactly.
Okay.
So it comes actually out of both sides of the black hole.
Okay, so it evens out. Okay.
Yeah, exactly.
That is amazing. Wow.
Yeah.
Okay. And you can observe the jets themselves or the actual bending of the jets? Is it one or the other or both?
It's both. You
Okay.
have to see the jets in order to really like see them bending back.
Okay.
And so that's kind of what we do with these radio telescopes is we can point them at one of these objects and we can start to see, oh, this one looks kind of bent.
Okay.
Interesting.
Wow, fascinating. That is absolutely great. I would love to talk another 2 hours about that, but I want to move on to something that is accessible by the general public. And thank you for explaining this to me, but please tell us what UITP is and how the general public can go to parks and learn stuff.
Yeah, absolutely. So UITP stands for Universe in the Parks. And it's this program that's been going on for 27 years or something along those lines. And essentially what happens is every summer, spring through early fall, I would say, members of the astronomy department at UW-Madison travel to state parks all across Wisconsin with a telescope and a projector. And the way it works is we'll just set everything up one night. One person will give a little talk about anything, honestly. It can be about what they study, or it can just be about a fun astronomy topic that they like. Okay. And the other person will use the telescope to look at the stars and show people either stars, planets, the moon, whatever they want to look at that night. So, of course, this part usually varies depending on the weather, but I've seen some really great things at UITPs, and they're really great events. So, you know, a nice way to enhance a summer camping trip, frankly.
Yeah.
I've done a lot of them, and it's a lot of fun to be able to just see the different parts of Wisconsin and meet so many people that are just curious about space, or were just camping and thought, why not?
Yeah. I can't believe I didn't know about this because I rock climb at Devil's Lake. I hike at Governor Dodge. I go, I'm in parks, whenever I can be. And I never knew about this. So how do we find out about the schedule? Is there a website?
That's a great question. Let me just see if it's really easily Googleable.
Yes, you have the knowledge of the universe in your pocket.
I'm just, Universe in the pocket is what it should be.
Right. It should be Universe in the pocket.
Yeah, okay. So if you Google universe in the park, you should be able to find it. Nowadays, it's happening through the Badger Talks program, University of Wisconsin.
Oh, great. Okay.
And they have a whole list of them.
And this is the Badger Talks podcast, so we are right in our universe.
Exactly.
We are in our galaxy cluster. All
Convenient.
Right.
Perfect.
I love that.
Yeah.
I am going to look that up because that would be really, really a perfect thing for me to do after a day of hiking or climbing is, go become smarter. I absolutely love that.
Yeah, exactly. And it's all like you get to be smarter for free in a beautiful park. Who doesn't love that, you know?
I definitely can use that. I want to find out a little bit about you personally. And when I looked up on your LinkedIn profile, it was very funny because it was like 3 sentences. It was Melissa studies galaxies and their environments, and you love your dog. So tell me about your dog. I'm an animal person, so I want to hear about your dog.
Amazing. His name is Roscoe. He's a black lab.
Oh, how great.
Yeah. I adopted him right before I came to grad school. He was like 6 years old or so. And so now he's getting up there in age, but he still acts like a little puppy. We just went to the dog park yesterday. He's great. And I've tried taking him. So I love doing water things, which makes Wisconsin a fun place to be, as long as, the water's not frozen. But I really love going kayaking, and I've gone paddleboarding a few times with him, and he's okay with it. He was really confused at first, but he's gotten used to it, and he hasn't flipped over the paddleboard yet. So
nice.
We'll see how that goes. I do want to plug one more thing.
Please do.
That the astronomy department has very recently started doing. And it's this event called Astronomy on Tap. And you can find these events all over the place in just kind of the weirdest little cities. But basically, wherever there's a group of astronomers, there might be one of these. And we go to various bars around town, whatever it is that we like to talk about. We have fun trivia. We have little giveaways. And
are these scheduled or are they just spontaneous?
They are scheduled.
Okay.
They are. And so we just finished up our first season, and it was really nice. But
what is this called?
This is called Astronomy on Tap. You're gonna have to look for the Madison one.
On Tap. This is great. Okay.
Yeah, and I mean, if you're ever traveling,
so 2 astronomers walk into a bar. Yeah, great. All right.
Exactly. Yeah. You're gonna have to ask them, like, how do you finish this?
Right. What's the end of the joke?
There you go.
Great. Okay.
Yeah, no. So they happen all over the place. If you ever find yourself traveling, just Google it, and there might be one there.
So you've got Universe in the Park during the summer. You've got Astronomy on Tap kind of the rest of the year. And these are things that we can all look up and see when and where these are happening and go. That sounds absolutely, that's wonderful. I love that kind of outreach where science gets out to the people.
Exactly. And I think with astronomy, people will sometimes call it one of the gateway sciences because it really does. I mean, it's so easy to just look at an image from Hubble or JWST and just be captivated by what's going on there in our own universe.
Right.
And I think it's a really fun opportunity. And I just love talking about science, as you could probably tell.
Yeah.
So I really love doing
learning
stuff
about
like this.
It's great. Melissa Morris, thank you so much. Melissa Morris is I'll just say they are a graduate student and really soon to become a PhD. Probably this Friday, right?
Yeah, this Friday.
Terrific.
That's the day.
So this is one of my few chances to interview you and not be calling you doctor, although soon enough that will be the case.
Yeah.
Wow. Terrific.
It's exciting.
Thank you so much.
Thank you. This is really great. This is fun to chat more about what I do.
You've been listening to the Badger Talks podcast. I hope you enjoyed my conversation with graduate student and soon-to-be PhD recipient Melissa Morris. Please browse our previous episodes for other topics that may be of interest to you. The Badger Talks podcast is a creation of UW Connects and produced at Audio for the Arts Recording Studios in Madison, Wisconsin. Our music is composed by Bill Purdy and performed by the UW Marching Band. I'm Buzz Kemper. Thank you for listening.